All right, so this is the review for the test. Some of these are a little messed up. The fill in the blank parts are not accurate for all of them, so I need to fix that. I apologize. But this one is fine because this is a simple interest problem, so this one works out fine. Okay, so the amount you're putting in is $700,000. Okay. The rate is 2%, which remember, we're not doing the TVM solver, so it's just 0.02. And now it says, if the lend at $700,000 overnight to Atlanta, how much interest will Atlanta owe St. Louis the next day? So that's just 1 day out of 360. Okay, kind of a weird one. We haven't had one like that yet. So basically, we're just going to type in 700,000 times 0.02 times 1 divided by 360. And what we get is $38.89. Okay. Now, if you were going to say what is the total amount, it would be, which is not in this problem, it would be $700,038.89. Okay. But the actual question they are asking is how much interest, so that's your final answer. Now, number 2, it says, it says you have $10,000, 6.9%, compounded daily for 10 years. Okay, so that is a compound problem. So this one, actually, this is the fixed one. You guys don't have this. I apologize. I don't know why I did not get the right one printed, but this is the updated one. So, again, sorry about that. So the interest rate is 6.9%. All right. The amount of money is $10,000. The payment is 0. Okay. The future value is what we're trying to calculate. Now it says daily, so PYCY is 360. Okay. And then it says over 10 years. This is going to be 10 times 360, so 3,600. All right. So we take our calculator and we go into apps, finance, TVM solver, and we're going to put in 3,600. All right, interest rate is 6.9. And if you're comfortable with all this, you can just, obviously fast forward through this. 10,000. Payment is 0. We're not putting money in. It's not annuity. And this is daily, so 360. And when we put in PY, CY changes, go up to future value and hit alpha solve. Okay. Now, the question is, how much interest will be accumulated? So this is the amount, $19,935.84. Okay. So the future value is $19,935.84. But the question is not for the future value, it's the interest. So we have to subtract the $10,000, which means the final answer for this problem is $9,935.84. Always make sure you pay attention to what the question is that is being asked. Don't assume. Okay, number 3. Ford Motor Company sells its F-150s for $19,875 with a 2.5 interest rate financed for 4 years. You take out a loan, how much will your monthly payment be? Okay, so this is a loan, so this is you get an amortization schedule of payments. Okay, so the interest rate is 2.5. Present value is $19,875. The payment is what we're trying to figure out. Future value of any loan is 0, and we're talking monthly. And it's for 4 years. This is 12 times 4, which is 48. So we go to our calculator. We go up here. And we put in 48. The interest rate is 2.5. The amount we're borrowing is 19,875. This did not ask for a down payment, so that is the amount of money we're borrowing. Payment is what we're trying to calculate. Future value of any loan is 0, and this is a monthly loan. We go back up here to payment and hit alpha solve to calculate, and we get 435.54. This one says keep it the same, so 435.54. All right, number 4. How long will it take to accumulate $1 million if you put in 100 per month into annuity? Well, no trick question there. It's an annuity. 8.5 compounded monthly. So interest rate is 8.5. You're putting no money in to start, but you're putting in 100 per month. Okay? Future value, you're trying to accumulate $1 million. So 1 with 6 zeros. Okay? And this is going to be 12, basically X. Okay? 12 times the number, 12 times T for time. So when we get our answer in the calculator, we have to divide by 12. Now remember, when we are trying to calculate this, okay, if we do it the way we have it, okay, so we leave that blank, or the first one blank, we're going to put in 8.5. Present value 0. We're putting in 100 per month. The future value is 1 million. 1, 2, 3, 4, 5, 6. And we're doing it monthly, so that stays the same. So we're coming up here to calculate alpha, enter, and we get an error. Okay? So you hit 2 to go back to it. This is the one time where it does matter. You have to put in negative 100. Whenever we're trying to calculate for interest or time, you have to put the negative 100 in. It just messes up. So there we are. It's 605.57. Okay. So if we do 605.5 divided by 12, we can do that right there. We don't have to quit and go out. It's about approximately 50 and a half years. Approximately. Okay? So remember, I'm not really a stickler about putting the negative there. It just, usually if we get a negative for the future value, we just throw that out. But technically, you're supposed to put it in there. It's just not a big deal unless you're solving for one of these two. And it's not a big deal. If you get the error, just remember that means put a negative in for your payment. Okay? Simple fix. Number 5, parents are putting $25 per month into an account. Well, that's the payment. That earns 8% on the day their child was born. How much will be there in 18 years? So 18 years, and it is monthly. Future value is what we're trying to figure out. They didn't have any money in the account. We're doing a monthly payment, so there's an annuity. Okay? I think we're pretty good on the calculator. So just enter these in. All right? And remember, you can just type in 18 times 12. Okay? And so this is going to be $12,002.15. So we put them all in, calculate alpha solve for future value. All right, a 2-story, 4-bedroom house with a 2-car garage in the neighborhood sells for $235,000. The local bank offers a mortgage of 7% for 30 years. What's the monthly payment? Again, car and home loans are amortized. I can't speak today. So it's an amortization schedule. All right. Again, not asking for a down payment. All right. If there was, like, say, a 10% down payment, you would multiply this by 0.10. If it was 20%, 0.20, and so forth. Okay? So the present value on this one is $235,000. That's the amount of the loan. We're trying to calculate the payment. Any loan is 0. It's a monthly payment. The interest rate is 7. And it's 12 times how many years? 30 years, which is 360. Again, I think we're good on the calculator. So you put all these in. Alpha solve here, and you end up with $1,563.46 per month. Don't forget the change, okay, and round properly. Now, what is the total amount paid for the house after 30 years? Okay, so that's going to be the monthly payment of $1,563.46 times 12 times 30, or just times $360. No, sorry, 360 payments, which works out to the sad amount of $562,845.60. To find out the amount of interest, you're going to take this amount right here minus the 235. So again, that's going to be 562,845.60 minus 235,000, leaving us with a grand total of money that the bank makes off of our loan of $327,845.60. Ouch. Now, number 7, we got 2 more. First Union Trust Bank offers a loan rate of 7.75 for 30 years. If you can afford a monthly payment of $700, that's payment, how much of a loan can you take out? We're trying to calculate the original loan. All right? Future value of any loan is 0. It's a monthly payment. It's 12 times 30, which we know is 360. Okay? We haven't done payment present value, so let's do that just for the heck of it. It's 360 right here. The interest rate is 7.75. The present value, we don't know. Payment's going to be $700 a month. Future loan of any value is 0, monthly, so present value, alpha, solve. Notice it's negative. Okay? Oh, look at my payment. I was like, that's way small. My payment only was 70 when it should have been 700. One of the zeros didn't show up. Let's move that decimal over a bit, and that's all it's going to be. It's going to end up right here. So alpha solve. Yep, there it is. So 97,709 and 11 cents. The 5 tells the 0 to round up. So 97,709.11. And last but not least, almost last but not least, I forgot there's 9. Math is hard. All right. Your pension fund for retirement. Oh, I think I also forgot to do this one. This was also a loan, so it's amortization. Sorry about that. So your pension fund for retirement is $180,000 and is earning 8% monthly. How much could you withdraw each month for the next 20 years before depleting the account? Okay. So there's an annuity because we're trying to calculate the payment because we're reverse doing it. All right. So it's monthly times 20 years. So that's 240. The interest rate is 8%. The present value is 180,000. Trying to calculate that. Future value is 0 because we're going to use all of the money. And this is monthly. So again, nothing new here. We're going to put all those numbers in, calculate alpha solve right here, which will give us $1,505.59 each month. All right, last big one here. Warren Buffett put $800 a month into a bank account. Well, that's a monthly payment, earning 5%, compounded monthly for 3 years. So 12 times 3. At the end of the year, at the end of this time, you took it out and put in, we'll get to that in a minute. So we're going to calculate the present value right here. Right? Wait, was it 800? Oh, I'm sorry, my bad. It's 8,000. The present value is 0. We're actually calculating the future value. Sorry. So present value is 0. They're putting 8,000 a month. That makes it an annuity because we're putting in a monthly payment. Go ahead and we calculate this right here, alpha solve, and what we get is 31026.68. So $310,026.68. Now let's see what it says. It says he took all the money out in the account and bought a bond paying 9%, compounded semi-annually for 6 years. So that's a compound interest problem. This is going to go down here for present value. So 310,026.68. Okay. 9% compounded semi-annually. That's just twice a year. At the end of 9 years, that's twice a year for 9 years is 18 payments or 18 periods. Okay. He's not putting in any payments anymore. We're trying to calculate this. So we go ahead and enter that into our TVM solver, and what we get is $525,768.49, and that is all.